Now let's see the next class of parsers. The next class of parsers are this: LALR1 and CLR1. So these are the two parsers I wanted to construct, and as we have seen, for all the parsers the parsing procedure is same, the parsing algorithm is same. Only thing that is going to vary is the construction of parsing tables. So if we have seen this LR0 in the construction of parsing table, we are going to place the reduce move in the entire row, and if you see this SLR1, we have placed the reduce move only in the follow of left hand side. And similarly here, in order to construct LALR1 and CLR1, we are not going to use canonical collection of LR0 items, we are going to use canonical collection of LR1 items. So in case if we have seen SLR1 and then LR0, we have used canonical collection of LR0 item. What is LR0 item? Any item with dot in the right hand side is LR0 item. LR1 item is nothing but LR0 item plus a look ahead. So if we add look aheads to LR0 items, then we are going to get LR1 items. For example, if I have any production, let us say, what is LR0 item? Any production with dot on left hand side, on right hand side, right? So let us say a production is like this: dot A. This is nothing but LR0 item, right? Now to this LR0 item, I even add some symbols which are called look aheads. So what is the importance of these look aheads is, whenever we reach the final item, for example, if the final item is sderives AA dot, and at that place if the look ahead is like this C comma D, it means that don't place the reduce move in the entire row or in the follow up left hand side, just place it in the look ahead symbols. Therefore these look aheads are going to be useful in order to determine where we are going to place the final item. So I'll take an example and I'll show you how does this canonical collection of LR1 items are formed. Let's see the example where, even we have seen one example in the beginning. This example is sderives A derives small a or b. So for the same example, we have constructed LR0 and SLR1 parsing tables also. Now for the same example, I want to show you how to construct the canonical collection of LR0 items. So always remember, we have to start with the augmented production. So augmented production is s dash derives dot s. It is nothing but LR0 item. You have to make it LR1 item. So for the initial production, always start with this, with dollar. Dollar is the look ahead. So for the augmented production, this is LR0 item. In order to make it LR1, I am going to add a look ahead, and the look ahead is always dollar for the augmented production. Now since there is a dot to the beginning of S, you have to add all the S productions. See, since there is a dot in the beginning of S here, I am going to add all S productions. What are S productions? S derives AA with dot in the beginning, and now you have to add the look ahead symbol. Now why did I add this production? I have added this production because of this dot before the S. Whatever is remaining after it, what is remaining after it? Dollar. You have to find first of that and add it here. So I'll tell you the rule. In case if you are going to do the closure for A derives alpha dot B beta comma, let us say A or B. If this is the production, and because of this LR1 item, if you are applying the closure, then you have to add all the B productions with dot in the beginning, and now you have to add the look ahead. Look ahead is going to be, we have added this B production because of this B. Whatever is remaining after that, what is remaining after that? Beta followed by A or B. Find first of beta followed by A or B and then add it. So let us say first of beta is C or D, then I am going to add C comma D here. Okay. Or in case if there is no beta, then we have added this B production because of this B. Now whatever is remaining after that, what is remaining after that? A or B. Therefore we have to add A or B here. Okay, so remember this. Now how did I do it? There is a dot to the beginning. Whenever you add any production, just see the production because of which we added it, and then in that production whatever is remaining after that variable, you have to add all the all the find first of it and then add it as a look ahead. Okay, now see this. Why did I add this production? I added this production because of this S. Now what is remaining after that S? Only dollar. So what is first of dollar? First of dollar is dollar. Okay, now I have to add A productions because of dot before this A. Therefore I am going to add A productions. A derives dot AA or dot B. Now why did I add these A productions? Because of this A. Now what is remaining after that A and dollar. So what is first of A dollar? Are you getting this? See, what is remaining after this? The next remaining symbols are A dollar. I added this production because of this A, and whatever is remaining after this, which is nothing but A dollar, I have to find first of that. So what is first of A dollar? First of A dollar is nothing but first of A, which is nothing but A or B. So here the look aheads are going to be AB, and here also look aheads are going to be AB. Got it? So this is nothing but I naught. I naught is nothing but canonical collection of all collection of all LR1 items starting with S dash derives dot S. So I have taken the first production and I applied the closure. Now remember that whenever we apply the transition, which is nothing but, if I apply transition on capital S or on any symbol, the look ahead doesn't change, which means S dash derives S dot, and whatever was the look ahead you had to write it there. Okay, and let us say what happens on capital A. On capital A, if you see this, then S derives capital A dot capital A, because I am moving this dot to right of first A, comma dollar. Why? Because the look ahead was dollar, and now because of this dot before this A, there is a dot before capital A, I am applying the closure. So when I am applying closure, I have to add all A productions. What are A productions? A derives dot AA or dot B. Now why did I add this A production? I have added this A production because of the second A. These A productions are added because of the second A. Now whatever is remaining after second A, what is remaining? Dollar. So what is first of dollar? Dollar and dollar. They are the look aheads here. Got it? And no more symbols will be added. No more productions will be added because we didn't get any dot to the left of a variable. Okay. Now let's say on small a. On small a, what happens? This dot has to be moved to the right of small a. A derives small a dot capital A, and whenever we are applying the transition, whenever we are moving the dot, we need not change the look ahead. So look ahead is going to be A or B, and now because of dot to the beginning of this A, I have to add all the A productions with dot in the beginning. So I am going to add A productions. A derives dot AA or dot B. Observe this. Now I am just adding this A productions, which is already added, right? So this production AA is already there. Again I am adding AA, but then these two productions are different in terms of LR0 items. Even though the productions are same, LR0 items are different. This LR0 item says that we have seen till small a. This LR0 item says that we have not seen anything, right? So both are different. Now what should be the look ahead? Look ahead is, see this. Why did I add this second A production? I added this second A because of the dot before this A. Now whatever is remaining after it, what is remaining? A or B? Find first of it. What is first of A or B? It is simply A or B. Okay. And now this one on small b. On small b it is going to give A derives small b dot or look ahead is going to be A or B. While applying the transition, don't change the look ahead. While applying the closure, look ahead might change, right? And now what about this on capital A? On capital A, S derives AA dot comma dollar. We are not changing the look ahead, and this is the final item. And what about this on small a? On small a, it is going to give us, see, on small a it is going to give A derives small a dot capital A comma dollar. Why? I have moved this dot to the right of small a, and you might observe that this state and this production both are same, but then in terms of look aheads they are different, therefore they are different states. Okay, so even though in LR0 items they are same in terms of LR0 items, but in terms of look aheads they are different, therefore they have to be split into different states. Now see this, on small a I am moving capital A dot small a comma dollar, and now I have to add all A productions, right? What are all A productions? A derives dot AA or dot B. Now why did I add these A productions? Because of this dot before this A. Now whatever is remaining after that, what is remaining after that? Dollar, you have to find first of it. Now what is first of dollar? Dollar and dollar. Alright, so you have to make an observation here. These two states are actually having the same LR0 items but different look aheads. Here the look ahead is AB, AB, AB. Here the look ahead is dollar, dollar, dollar. Therefore they have to be in different states. Okay, and now let's finish this. Now what about this one on small b? This one on small b is going to give A derives B dot comma dollar. What about this one on capital A? On capital A we are going to get a final item. A derives A capital A dot, look ahead is A or B, and this one on small b is going to give us A. This one we have already seen it. On small b we are going to get the same production, right? So what about on small a? On small a we will loop to the same state, and this one also on small a we loop to the same state, and this one on small b is going to be A derives B dot. On small b it is going to be A derives B dot comma dollar, right? On small a it is that, and on capital A it is going to be A derives AA dot comma dollar. See, look at doesn't change when I am applying the transition. Okay, so on small a it is over, on capital A it is over, on small b it is over, right? And capital A, small b, right? So yes, so all these states are done. Now you just open the page where we have discussed the same grammar for canonical collection of LR0 items. Here I am discussing the grammar for canonical collection of LR1 items. You will observe one point. The number of states in this canonical collection of LR1 items will have increased. The reason is, previously these two states were not there, these two states were in one state. The reason is, whenever I consider the look ahead, because of the changes in the look ahead, I got these two states. If you look at LR0 items, in terms of LR0 items, both these states are same, isn't it? Both these states are same in terms of LR0 items, but when I consider the LR1 items in terms of look aheads, both these states are different, right? And moreover, you can even observe this state and this state, both these states are same in terms of LR0 items, but they are different in terms of look aheads, even these two states, right? So there are some states which are having same look aheads, which are having same LR0 items, but which are having different look aheads. Therefore, the number of states when I consider canonical collection of LR1 items might increase in general. Okay, and one more thing is, while constructing this, I can use this canonical collection of LR1 items, and I can construct, first one is CLR1 parsing table. So in CLR1 parsing table, the number of states will be equal to the number of states in this canonical collection, and always the go to part and the shift part is same as previous. So previously, however you have constructed this go to part and shift part, that is going to be same. So only difference coming to this CLR1, using this canonical collection of LR1 items is, where are you going to place the final items? Whenever there is a state which contains final items, whenever there is a state which contains final items like this, we are not going to place them in the entire row or on the follow up left hand side. In case of CLR1 parsing table, we are going to place the reduce moves only in the look ahead symbols, which means for this, in this state, for this reduce move, for this final item, a reduce move will be placed under small a and small b. That is the advantage of using this look ahead symbols. So previously, if you see this, in LR1, in LR0 parsing table, we are placing the look aheads in the entire row. And in SLR1, we are not placing it in the entire row, we are placing it only in the follow up left hand side. Now in CLR1, we are not placing it in the follow up left hand side, we are placing only in the look ahead symbols. Therefore, the number of reduced entries compared to LR0 or SLR1 is less in CLR1. Therefore, there will be less number of conflicts. Whenever I reduce the number of reduced moves, obviously the conflicts are going to be reduced. But then and moreover, whenever I reduce the reduced moves, the blank spaces are going to increase. So since the blank spaces are going to increase, the error detecting capability is going to increase. What is a blank space in any parsing table? It is nothing but the error. So whenever I have more number of blank spaces, it means that we are even increasing the error detecting capability of the parser. So the overall thing is, I'm increasing the number of states because of having look aheads, and I'm decreasing the number of these reduce moves because of having the look aheads. Now for the same canonical collection of LR1 items, I want to construct the parsing table. In order to construct the parsing table, instead of I could not, I may not be able to construct the parsing table side by side on the same board. Let us number these states. You also number these states in the same way I am numbering it. Later you can refer to this diagram when I am constructing the parse table. So let's just number them the same way so that our diagrams will be consistent. This, let us call that one as I0, and this one as I1, and this one as I2, and this one as I3, this one as I4, and this one as I5, and this one as I6, I7, and AA.I8, and this one as I9. No, I7 is already written. I7 and I9. Okay, these two states are already written. Now according to these numbers, you can observe one thing. So please number them according to this. So because the table is going to be, I'm going to construct the table according to these numbers. And before going ahead and then erasing it, I just want you to observe two things. One thing is, in this example, I3 and I6, yes, I3 and I6 both are having the same LR0 items but different look aheads. That is one point. And then I4 and I7, if you observe it, where is I4? I4 and I7, yes, I4 and I7 both are having same LR0 items but different look ahead. And then I8 and I9, so I8 and I9 both are having same LR0 items but different look aheads. So you just keep that in mind, because when I'm constructing LALR1 parsing table, I'm going to merge these states. Okay, so let me now show you how to construct the CLR1 parsing table from this canonical collection. Okay, this is the CLR1 parsing table for the previous example. So please refer to the state numbers that I have shown you, previously. If you write the state numbers accordingly, you are going to get this parse table. So in this parsing table, one thing you have to observe is the shift moves and go to moves, they are same as LR0 and SLR1 parsing table. Only difference is whenever you have reduce moves. So if you look at the fourth state, so what is R3 is this, see this. Now let us say the first production is S derives AA is production number 1, and second production is A derives small a capital A is second production, and then A derives, small b is third production. R3 means it corresponds to this. Now if you look at the fourth state, I4, you will see that there is a production like this with dot at the ending, A derives B dot, which means a final item, and then the look aheads will be A comma B. That is why only under A and B I am placing the reduce move. Okay, and if you look at I5, the production will be S derives AA dot, this is the final item, and the look ahead symbol will be dollar. That is why only under dollar I am going to place this R1, right? So, and even the same thing is true with I7 and I8. So only difference between LR0, SLR1 and CLR1 is the placement of reduce moves. And one thing you have to observe is, for the same grammar, if you construct canonical collection of LR0 items, and if you try to construct the LR0 or SLR1 parsing table, you will get only 7 states. But in CLR1 parsing table we got 10 states. The reason is we got few states which are same in terms of LR0 items but different in terms of look aheads. Since we are having look aheads, the number of states may increase. So here the number of states have increased and number of reduced moves have decreased. Therefore obviously conflicts are going to be less. Now this is CLR1 parsing table, and we have seen that the size of CLR1 parsing table is very big. So if you observe this, the states I3 and I6 in the previous diagram, the states I3 and I6, they have the same LR0 items but different look ahead, and then I4 and I7, they have the same LR0 items but different look ahead. Similarly I8 and I9. So what you could do is, we could merge these states into one state, which means if I merge I3 and I6, and if I make a new state I36, and if I merge I4 and I7, and if I make a new state I47, and if I merge I8 and I9, and if I make a new state I89. Okay. Now by merging these states into single state, what we could do is, we could actually reduce the size of the CLR1 parsing table. How I could reduce the size of CLR1 parsing table is, wherever there is 3 or 6, I am going to replace it with 3, 6. And now by doing this, what we are actually achieving is, even though because of look ahead item, look aheads, two states are going to be in different states, or a single state is going to produce two different states because of look aheads. By merging them back, I am actually making the look aheads irrelevant. Therefore, if I merge these states, I will again get the 7 states, right? So you should understand one thing. Now coming to the number of states in LR0, the number of states in LR0 is equal to number of states in SLR1. This one we are very sure. And now because of adding look aheads, the number of states in CLR1 actually have increased. The number of states in CLR1 might increase sometimes, or they may not increase. And when I merge these states which are differing only in the look aheads, I am actually combining these states. See what is happening is, I am merging these states which are different in look aheads. Therefore I am merging some of these states, and again I am achieving the same number of states in LALR1 parsing table as they were in LR0 or SLR1. Therefore number of states in LALR1 is also equal to LR0, SLR and LALR. All the states, the number of states in all these 3 parsers will be same, but then there is a slight increase. There might be an increase coming to CLR1. So let's see how to convert this CLR1 table into LALR1 table. So in order to construct CLR1 table, we considered the canonical collection of LR1 items, and then we have constructed the table, and then I have seen that there are some states which are differing only in the look ahead. So I am going to combine only those states. So wherever there is 3 or 6, I am going to write it as 3, 6. Now 3, 6 is a new state. See, here there is shift 3. Now I am going to write it as shift to 3, 6. Shift 6, 3, 6, 3, 6. I should not write R3 as 3, 6, because this reduce move is nothing but the production number, and the shift move is nothing but the state number, right? And then S 3, 6. Okay. So wherever there is 3 or 6, I am going to write it as 3, 6. So we don't need 3 or 6, I am writing it as 3, 6. Okay. Now wherever there is 4 or 7, I am going to write it as 4, 7. So here there is 4, 7, and here there is 4, 7, 4 7, and again this is also going to be 4 7. Okay, and wherever there is 8 or 9, I am going to write it as 8 9. So there is no S8 or S9, so you could write it as, yes, here there is 8 9 and here there is 8 9, right? So now change it even in the row numbers, 4 7 4 7 8 9 8 9. So we have converted, we have combined two states into one state. Now we don't need 2 3 6s. So see this, I am going to see this 3 6 state and then this 3 6 state, they represent the same state. Therefore I am erasing it. I am erasing one of it. Okay, and now I don't want 2 8 9s. So I am going to erase it, but then once if you have to erase this 8 9, you see that the effect is is being replicated here. So that is the reason before erasing this I have to union them, merge them. Merging them is nothing but R2. Then you can delete it. And see this 4 7 also. In 4 7 again there are two 4 7s, merge both of them, then you are going to get R3 here. Got it? So that is how this is again CLR, this is again LALR1 parsing table. So from CLR1 parsing table I converted it to LALR1 parsing table. So how did I do it? Whenever there are two states which are having same LR0 items but different look aheads, I am going to merge those two states into a single state. Therefore the final number of states are again 7. So LALR1 parsing table, LR0 and SLR1, all of them will have the same number of states, and number of states will be equal to the number of states in canonical collection of LR0 items. In CLR1 parsing table, the number of states could be more because of adding look aheads. Okay, so let's see some more examples and you will understand it better.